Determine the particular solution for the differential equation y prime plus negative 1 over x squared y equals cosine x times e to the minus 1 over x. Okay, we want the particular solution that has y at 1 equal to 0. So that's our initial value, that's our given value. Okay, so first we're going to have to find the general solution to this differential equation, which is already written in standard form, so that's going to be nice for us. Okay, especially the presence of that plus sign with the minus sign grouped over here. So it's very easy to identify our p of x function from standard form. Just double check that we've got it correct. Okay, so it's already in standard form. We can jump straight into finding an integrating factor and then a general solution. And from a general solution, we can find the particular solution that our given values are specifying. Okay, so our integrating factor is the next thing to work out. It's e to the power of any antiderivative of our p of x once it's been identified. Okay. So can we think of an antiderivative for negative 1 over x squared? 1 over x will do the trick. So e to the 1 over x will do the trick for our integrating factor. Okay, once we've got an integrating factor, we multiply both sides of our expression by it. Okay. The left-hand side here is really just an expansion of our integrating factor times y, well, the derivative of that, using the product rule. And over here, we can see our e to this cancel out, and we're left with cos x. Now, we integrate both sides. And on the left-hand side, we'll be left with our integrating factor times y. And on the right-hand side, we need to think, do we know what the antiderivatives of cosine x look like? Sine x plus some constant. Okay. Now, if we divide both sides by e to the 1 over x, we've got y, and that's our general solution, which we might choose to write a little differently. Okay. So we could leave it like that, or I suppose we could even do sine x plus c, and then e to the minus 1 over x, in case we don't want denominators, but we don't want too many symbols. Okay? So whichever one we want to use is fine. We're not actually here for the general solution. We do need it, because one of the solutions we want is part of this general solution expression. We need to find the right value of c. And this is where we go back to the question and figure out our initial values, our given values, and we are told that y at 1 is equal to 0. Okay, so 0 is y at 1. So that's sine at 1 plus the constant we seek, e to the negative 1 over 1. And this needs to be equal to 0. Now we've got sine at 1 plus c, and then e to the minus 1, or 1 over e. Now there's no way that that's 0, so we could multiply both sides by e, and see that 0 needs to be sine at 1 plus c. And we're in radians. Sine 1 doesn't really have a nice value, so we'll just leave it like that. If we bring it over to the other side, we have our value for c. c is negative sine 1. Okay. A little unusual, but there it is. And so now, our specific function, our particular solution, looks like this. Sine x minus sine at 1, all times e to the minus 1 over x. So we went from general solution to our specific or particular solution.